Hello students, welcome to physics class. In previous class we are talking about the moving charges and magnetism chapter. In that chapter we start our discussion with the magnetic field. What is the magnetic field and what is the direction of the magnetic field? The experiment which gives the evidence for the magnetic field direction, Oersted experiment, that is Oersted experiment. Also we discussed that Oersted experiment tells us about the presence of magnetic field and source of the magnetic field, and it gives the direction of the magnetic field. We discussed these are all things, and also we discussed magnetic force. What is the magnetic force? See, we know that magnetic force formula is given that F is equal to Q into B cross V or V cross B. V cross, here force is a magnetic force. It is magnetic force. Q is charge, V is the velocity of the charge, B is the magnetic field. You can write like this also, VB sin theta. This is the F. Already I explained this F formula and what is the magnetic force. Find the charged particle if it entering or if it is moving in a uniform magnetic field, it experiences some force. It experiences some force. That force is magnetic force. But that again condition arises. What is theta? Theta is the angle between the velocity vector and the magnetic field. The angle between the velocity and magnetic field, that angle is nothing but the theta I used here. Q is the charge which is moving in a magnetic field, and this magnetic field, this magnetic force is always, this magnetic force is, what is the direction of magnetic force? This magnetic force is always perpendicular to the plane containing V and B. V and B, they are both are lying in the same plane. To that plane F is perpendicular. Means just like a vector screw rule what we can studied in the first year, the same. If velocity and magnetic field both are like this, velocity and magnetic field, if they are lying in the same plane, then force is like this. This is to say the direction of this magnetic force, we use the left hand rule, Fleming's left hand rule, or thumb rule also you can use it according to screw rule or thumb rule, but left hand rule also you can use it. How to apply this magnetic direction of the magnetic force using the Fleming's left hand rule? You take your left hand and hold three fingers, forefinger, mid finger and thumb. Each are perpendicular to each other. Every finger should be perpendicular to each other in such a way that you just hold it. This forefinger indicates the magnetic field direction. This mid finger indicates the velocity. These magnetic field, mid finger indicates the velocity. If magnetic field and velocity both are lying in the same plane, then the force is perpendicular to these two vectors, M and V, or magnetic field B and V. This forefinger indicates the magnetic field, mid finger indicates the velocity, and thumb indicates the force. This all just a brush up in your memory. Already we discussed in detail. Okay. Next, I also discussed some properties regarding this magnetic force. When the magnetic force is maximum, when the magnetic force is minimum. See, if theta is equal to 0, or if theta is equal to 180 degree, F is force, F is minimum, F is minimum. when theta is equal to 0 or 180 degree. See, what is the theta equal to 0? Theta equal to 0 if I consider sin theta is equal to 0, sin theta, sorry, sin 0, in place of theta if I write the 0, sin 0 means 0, therefore total value is 0, f is 0, therefore minimum value of the force it is when if theta is 0. What is the theta? Theta is the angle between the V and B, magnetic field and velocity, magnetic field and velocity. The angle between these two is theta value. If this angle is 0 degree, means when the angle between the velocity and magnetic field is 0 degree, then force is minimum. What is the meaning of this 0 degree? 0 degree means velocity and magnetic field both are in parallel. What is the meaning of this one? Velocity and magnetic field both are parallel means in the same direction of the magnetic field, in the same direction if the particle is moving. If the particle is moving in the same direction of the magnetic field, magnetic field ಯಾವ ಡೈರೆಕ್ಷನ್ ಹೋಗಿರುತ್ತಲ್ಲ ಅದೇ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆಗಿತ್ತಂದ್ರೆ ಅವಾಗ ಏನಾಗ್ತದೆ, ದ ಆ್ಯಂಗಲ್ ಬಿಟ್ವೀನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆ್ಯಂಡ್ ದ ವೆಲಾಸಿಟಿ ಈಸ್ 0. Or here 180 degree also similar way. Magnetic field is moving in this way or is along this direction, the charge particle is coming in this direction, both are exactly opposite, then also the force is minimum. If the theta is equal to 0 means charge particle velocity and the magnetic field both are in the same direction. 180 degree means if the charge particle velocity and the magnetic field both are in opposite direction, then the force or magnetic force is minimum. Similarly, one more time we discuss, if theta is equal to 90 degree, what happens? F is maximum. F is maximum if theta is equal to 90 degree. What is the theta? Again same, the angle between the V and B should be 90 degree. If V and B is 90 degree means velocity and magnetic field both are 90 degree perpendicular with each other. Magnetic field in this direction, then velocity should be like this. This is the meaning. If the magnetic field and charge particle both are in perpendicular with each other, then force is maximum. What is the value for this one? Maximum ಅಂದ್ರೆ ಎಷ್ಟು ಇರಬೇಕು? Maximum means it is not infinity. How much it is? Its maximum value is F is equal to QVB. This much. This is the maximum value. Why it is like this? If theta is equal to 90 degree, sin 90 means it is a 1 into QVB is equal to QVB, therefore F value is this much. This is the maximum value of the magnetic force. This is the minimum value of the magnetic force. Minimum. How much minimum means? F is equal to 0. This is the minimum value. These are all we discussed in the previous session. Next we move to the one more force, that is a Lorentz force. Already we studied about now it is about the magnetic force. Next we are going to study that Lorentz see how beautiful it is. What is the Lorentz force? See, in previous means first chapter we studied that electric field is equal to force by charge. We know this formula in previous chapter, first chapter. Electric field and charges and electric field chapter is there. In first chapter we studied this equation. Okay. Next, see, I want this F. Therefore, F is equal to, how can we write? E into Q or Q into E. This is the also force. This is also force. Already we studied this in this chapter. This is a force. Here left hand side both are indicates the force. This is a magnetic force. this is the electric force. When the charged particle, if it is moving in an electric field, then that charged particle experiences this much of force. For to avoid the confusion, I use the symbol E, small e, only to show that this force is because of electric field. I use the one more symbol B to show that this force is because of magnetic field. See, both are forces only, but when the charged particle moving in an electric field, this much force experiences. The same charged particle, if it is moving in a magnetic field, it experiences this much of force. From this we can understand, if a charged particle moving in an electric field, it experience some force. Okay, fine. The same charged particle, if I send it into the magnetic field, then it experiences some more force, some other force. Both time it experiences the force. That's fine. In both cases, if it experiences the force, then remember, if I apply the both magnetic field and electric field simultaneously, what happens? In electric field, if you send, it will experience force. If you send the same charged particle in a magnetic field, it experiences the force. If simultaneously, if I apply the electric field as well as magnetic field on moving charge, then it experiences the force. Then what is the net force? That is called Lorentz force. What it means? Magnetic field ಒಳಗೆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆದರೂ ಅದಕ್ಕೆ ಫೋರ್ಸ್ ಆಗ್ತದೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ ಆದರೂ ಕೂಡ ಅದಕ್ಕೆ ಫೋರ್ಸ್ ಆಗ್ತದೆ. ಎರಡು ಎಟ್ ಎ ಟೈಮ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಅಂದರೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಇದರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು ಕೂಡ ಐತಿ. ಎರಡೂ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತದೆ? ಹೌದು, ಎರಡೂ ಇದ್ದರೂ ಕೂಡ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಗಲಿಕ್ಕೆ ಬೇಕು. ಅದಕ್ಕೆ ಆ ಫೋರ್ಸಿಗೆ ಏನಂತಾರೆ? Lorentz force. Lorentz force is the force acting on a moving charge due to the electric field as well as magnetic field. Magnetic field ಮತ್ತು electric field ಎರಡು ಫೀಲ್ಡಿಂದ ಬರ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ ಎಷ್ಟತ್ತು? ಎರಡು ಕೂಡಿ ಸಪ್ರೇಟ್ ಆಯ್ತಲ್ಲ. ಎಟ್ ಎ ಟೈಮ್ ನಾನು ಮಾಡಿದ್ದೀನಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಇರ್ತದೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಇರ್ತದೆ. ಆವಾಗ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗ್ತೈತಿ? ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತೀವಿ? ಲಾರೆನ್ಸ್ ಫೋರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ ಕ್ಯೂ ಇ, ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕ್ಯೂ ವಿ ಬಿ. See, the force on a moving charge, the force on moving charge Q due to the electric field and the force on moving charge Q due to the electric field and magnetic field is called Lorentz force. Is called Lorentz force. The formula, see, Lorentz force FL, take it as FL because of Lorentz force. To say that it is Lorentz, I use the L. FE plus FB, FE plus FE. What is the FE? It is the charge due to electric field, force due to the electric field. FB means force due to the magnetic field. electric force plus magnetic force. What is the formula for the electric force? Just a couple of minutes I wrote this formula. Electric force formula is given by Q into E plus Q into V cross B. See, magnetic force formula, electric force formula as it is. Here Q common is there, keep outside, plus V cross this is the Lorentz force formula. This is Lorentz force formula. Next we move on to the definition of and assignment of the magnetic field. With the help of this magnetic force formula, we can define the magnetic field. But before that, you just understand what is the Lorentz force. Just once again I will repeat. It is the force due to the Lorentz force means it is a force on a moving charge Q due to the electric field E and also due to the magnetic field B is called Lorentz force. Lorentz force ಅಂದರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎರಡರಿಂದ ಬರ್ತಕ್ಕಂಥ ಫೋರ್ಸ್ ಎರಡು ಕೂಡಿ ಬರ್ತಕ್ಕಂಥ ಫೋರ್ಸಿಗೆ ಏನು ಅಂತ ಹೇಳ್ತಾರೋ ಲಾರೆನ್ಸ್ ಫೋರ್ಸ್ ಅಂತ. If you kept the only electric field, it experiences electric force. If I send the charge particle in a magnetic field only, it experiences the magnetic force. But if I apply both electric field and magnetic field, then Lorentz force. What is the Lorentz force? See, it is a force on a moving charge due to the electric field as well as magnetic field. Next, definition of assignment of magnetic field. Definition of magnetic field. Magnetic field. Definition of magnetic field. And SI unit. See, what is that? This one. We'll check. The magnetic field SI unit. The magnetic field SI unit is Tesla. Tesla. The magnetic field SI unit is Tesla. What is the one Tesla? I will discuss. That we'll discuss later. What is the magnetic field SI unit? SI unit can measure in terms of Tesla. Okay. What it means? With the help of magnetic force, we can define this magnetic field. We know that, remember, we know that magnetic force FB, that is a FB is equal to QV cross B. That is a QVB sin theta FB. We know this formula. We know this formula. With help of this formula, we can define the magnetic field B. We can understand the magnetic field B. What is that? What is the magnetic field B? See, magnetic field can measure in terms of Tesla. Tesla means scientist name. That same thing we are using as a SI unit, Tesla. To say that magnetic field should be in 1 Tesla means we can define with help of this magnetic force. The magnitude of the magnetic field, remember definition, magnetic field definition I am giving, or the magnitude of magnetic field. The magnetic field is said to be 1 Tesla, 1 T short, because Tesla can shortcut, we can write it as T. 1 Tesla when 1 Newton force is acting. 1 Newton force is acting on moving charge on moving charge unit charge, not one only charge, moving unit charge that is a 1 coulomb. Unit charge means 1 coulomb. Perpendicular moving perpendicular to B, that is moving perpendicular to the magnetic field B, magnetic field B with the speed 1 meter per second. This definition is look like lengthy, but actually everything is here only. This formula gives everything, whatever I given here, everything it will explain. See, we require B ಬೇಕಾದ್ರೆ ಏನು ಮಾಡ್ತಿದ್ವಿ, ಎಲ್ಲ ಈ ಕಡೆ ತೊಗೊಂಬರ್ರಿ. F B divided by Q V sin theta. Got it? If this B value should be 1, ಈ B value 1 ಆಗಬೇಕಾಗಿತ್ತು ಅಂದರೆ 1 ಟೆಸ್ಲಾ ಆಗಬೇಕಾಗಿದ್ರೆ F ಏನಾಗಬೇಕು, 1 ನ್ಯೂಟನ್ ಆಗಬೇಕಾ, Q ವ್ಯಾಲ್ಯೂ 1 ಕೂಲಂಬ್ ಆಗಬೇಕು, ಇಂಟು ವೆಲಾಸಿಟಿ 1 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಆಗಬೇಕು, ಸೈನ್ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ 1 ಆಗಬೇಕು. ಸೈನ್ ಥೀಟಾ ವ್ಯಾಲ್ಯೂ 1 ಆಗಬೇಕಾದ್ರೆ ಸೈನ್ 90 ಡಿಗ್ರಿ ಆಗಬೇಕು. ಸೈನ್ 90 ಡಿಗ್ರಿ ಅಂದರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಎವ್ರಿಥಿಂಗ್ ದೇರ್ ಓನ್ಲಿ. ಸಿ 1 Newton, 1 into 1 into sin 90, 1, therefore 1. See, everything is here. How beautifully it gives all the information regarding this force. The same thing what I wrote there, the same thing written here. See, what is that? The magnetic field is, the assignment of the magnetic field is Tesla. To say that the magnetic field is said to be a 1 Tesla. 1 Tesla ಆಗಬೇಕಾಗಿತ್ತು ಅಂದರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ 1 Tesla ಆಗಬೇಕಾಗಿದ್ದರೆ ಫೋರ್ಸ್ ಎಷ್ಟಿರಬೇಕಾದ್ರ ಮೇಲೆ 1 Newton force. The 1 Newton force is acting. 1 Newton force is acting. ಯಾವುದ್ರ ಮೇಲೆ 1 Newton force ಆಗಬೇಕು? The moving charge. On moving charge. How much charge? 1 coulomb charge. That is unit charge. On unit charge. And at what angle or at what direction? It should be perpendicular, that is a 90 degree, moving perpendicular to the magnetic field B. At what speed? Velocity V, 1 meter per second. This is the definition of the magnetic field. See, every time this magnetic field, not necessary to write this all the things, just to write the definition, that is enough. But only for your understanding purpose I wrote here. And one more thing you should remember, that is, every time we can't use the Tesla only. Tesla is a bigger one, therefore a smaller assignment we are using. Note, one more assignment, the small unit for B, that is a magnetic field, is Gauss. GAUSS, Gauss is the GAU, it is GAUSS, Gauss. What is its symbol is G. Symbol is G. Every time it is very difficult to write the Tesla in terms of Tesla. See, this Gauss is not assignment, remember, it is non-assignment, but sometimes we are using this also, because every time it is not possible to use in Tesla. That's why sometimes we will use this, even though it is not a assignment, but also we will use. What is its value is 1 Gauss is equal to 1 G is equal to 10 raised to minus 4 Tesla. 10 raised to minus 4 Tesla. Remember, this conversation is very important for your competitive examinations. 1 Gauss is equal to how much Tesla? 10 raised to minus 4 Tesla. And one more thing you should remember is note number 1 and second note number. See, this earth is a big one, very huge in size, and it has a magnetic field. It has a very heavy magnetic field. Even though it is this much of huge in size, but what is this magnetic field? It's 10 raised to minus 5 Tesla. The earth's magnetic field, earth magnetic field 10 raised to minus, earth magnetic field is of order 10 raised to minus 5 Tesla. See how much, even it is not a 1 Tesla also. Even though the earth is so much of heavy size, but its magnetic field is so less, that is a 10 raised to minus 5 Tesla. But don't think that it is one of very weak magnetic field. It is enough. Magnetic field, even though it is small, it looks like very small, but it is huge for human beings, because we are not that much of capable to handle the heavy magnetic fields. Even though it 10 raised to minus 5 Tesla, also it is a very big and very helpful to our mankind. It's very difficult to produce the complete 1 Tesla or 2 Tesla. It's very difficult. In artificial also, it is not so easy to develop the very heavy high magnetic field. Even Earth's magnetic field is 10 raised to minus 5 Tesla. See, every time we are not using the Tesla, instead of Tesla we are using the Gauss. Gauss is not a assignment, it is non-assignment, but also we can convert it. 1 Gauss is equal to this much of Tesla, 10 raised to minus 4 Tesla. You should remember this much in this class. Next class, I am going to handle the magnetic force on a current carrying conductors. What I used? F is equal to QVB sin theta. This formula is for the magnetic force due to the charge on a charge. Then, if the magnetic force on a conductor which carrying a current, that part we will discuss in the next class. Thank you.